So we continue our journey, which is to learn the pillars of object-oriented programming. And ever since we have started this journey, basically we have been working on some of the options that we have in the design of our applications, following the principles, the core principles of object-oriented programming. But along the way, we have left some very important topics, and in this video, I'm going to look to those topics that we seem to have left out. Cool. So as you write your applications, as you design your class types, and as your code, your application's code grows and grow, you will find yourself in a position where you have to add more and more members into the class type that you will be designing. So eventually, as you add more and more members, you'll find that the class becomes too big, which is a problem because it's going to be hard to maintain that big class. So in an effort to try to ensure that the process of maintaining your classes as they get more and more complex is simple to the best possible way, C# provides the notion of partial classes, which is the title of this current lesson. Partial classes. So what are partial classes? What are partial classes? I don't know. But here's how partial classes works. You are able to take your big class that you are designing, your big, huge class. You've got this big, fat class that you are designing. You are able to take it and break it into smaller pieces, into partial parts, so that it is easy to maintain your class as you design your class. So how do you do that? It's simple. We have a class called person here. Now we add members into persons. We add members, we add variable members, member variables, we add methods, we add events, we add delegates, we add all these sort of things. We also add inner classes, which are classes within classes, and this class gets big and it's hard to maintain it anymore. So the notion of partial classes allows you to take this big third class person to break it into pieces so that you are able to tackle these smaller pieces, like one by one. So for example, this is how you do that. You can make your partial class like this. Use the partial keyword to design a partial parts of your class, and say class person. Okay, so here maybe let's say you declare all your member variables into this part of the class. All your member variables goes inside here. So only member variables goes to that part. So you know that when you are looking to add a new member variable, you come to this part, you add it there. When you are looking for a certain member variable within your class definition, you come to this part and look it for here. So now you can have another part of this person class. You do the same to declare that part. Class person. You don't change any name here. Just write it exactly like this. And then here you add your automatic properties, for example. Automatic props. So we'll go here. So now you know that when you are looking to add an automatic property, you come here. So you can have as many parts of your class as you want. and it's up to you what you put within these small parts of your class. Person. Cool. So here you can have your methods. You can have your methods. So you can have as many parts of a person as you want. So that's basically how partial classes works. So then the users of this type are not going to see these parts. They are going to see one class, because what the compiler is going to do when you compile a code with this, it's going to create one big fat class, like we normally do define our class and the person, and take everything that is in this part and put it here, everything that is in the part and put it here, everything that is in that part and put it here. So now you have one big person class with all the members that you have defined into these parts of your classes. So basically this one is just help you so that you are able to manage your code as it's gonna come into smaller pieces. When you compile that, the compiler is going to take all the parts of the person type and create one big part. So that means the users are not going to see these parts, good people. They are going to see the whole class with all the members that are defined within each part of your class. That is simple as that. Cool. So the next thing to look at, it's the concept of abstract classes. We have actually touched a bit on abstract classes, though we did not directly say that we are talking about abstract classes, because we did talk about abstract members. So what we did not mention, however, is that abstract members can only be defined within abstract classes. Abstract members can only be defined within abstract classes. Cool. So the next thing that we are going to talk about is that of abstract classes. Are we together, people? So abstract classes, it's basically those types that provide the general functionality for all the types that are going to inherit from them. Are we together, people? We've got a class person. Let's say we are writing an application for a college. So there in college, obviously, we are dealing with people. But the problem is that in college, there are different types of persons. Employees themselves may be different. Administrator, a lecturer, financial department, that and that. And then there are students. So all these different types of people are persons. So all these people in this college that we are designing an application for, they've got some properties that are common amongst all of them. For example, in a college, everyone has an age. So all the members or all the properties that are common amongst all the types that are going to inherit from this type that you are designing, all of them, you actually identify all of the functionality that you find that, okay, each and every class, each and every member that is going to be based on this member that I'm designing need to have this functionality. So on your abstract classes are those kind of classes with those kind of functionality. The functionality that you want each and every member that is going, each and every type that is going to be based on the type that you are designing should contain. Slow. So person is a general, it's basically a general term in a college, because there are different types of persons in a college. So saying that you want to create an instance of a person, for example, it wouldn't really make sense within your application to have this part of the code. Though we have been doing it, it really doesn't make sense to create this kind of, or to have this line of a code. Because the first thing when I see this line of a code that I'm going to ask you is that, what kind of a person? An employee or a student? Is it? So creating an instance of a type that is so ambiguous does not really make sense practically. So the classes that can be so ambiguous, like the person class, need to be made abstract, and then once you make your type abstract, what you are basically saying to those who are going to base their types on your type is that they should not create an instance of the type. John, this is how you make your class to be abstract. Our class is now abstract. Our class is now abstract. Ne? So, this line of code is now wrong, because the compiler is going to tell you you cannot create an instance of an abstract class. Creating instances of abstract class, it's not allowed in C#. Fine. Abstract classes, again, define a set of abstract members. So within the abstract class, you must have a set of abstract members. And we said abstract members are members that do not provide a default implementation. They don't provide an implementation. All you see within the set of abstract members of an abstract class, it's basically signatures for those members. Because normally the types of members that you will find within an abstract class should be properties or methods. You really will not have member variables within an abstract class. Why? Because we said member variables are used to store the state of an object. So we say abstract classes, you can't create an instance of an abstract class. That means you cannot have objects that are of type that have a type which is an abstract class. Jim, what do you know? I say you are not allowed to create instances of abstract classes. So you can't have this type of a code. You can't create an instance of an abstract class. Cool. So then it doesn't make sense to have a member variables that are used to store the state of an object when you are not allowed to create an object of that type. So you are not allowed to create an instance of a type. You are not allowed to create objects of an abstract class. So within the abstract class, it won't make sense to define member variables. That is, members that are used to store the state of an object, because you are not allowed to create objects of that class. So the type of members that you define within an abstract class are members such as properties and methods, and you make them public. So those are the types of members that you must define within an abstract class. So then you only provide the signature for those. You don't provide the implementation. Once you try to provide an implementation, it's an error. So within an abstract class, you're going to have something like this. Public abstract. You use the abstract keyword to define abstract types. And then we say int get age, and then you leave it like that. You don't provide implementation. Once you try to do something like this, then you say, okay, I'm going to provide my implementation here. That's wrong. The compiler is going to complain. You are not allowed to provide an implementation of an abstract member within an abstract type. Hey. So you only give the signature. So now, those who are going to base their types from this type have the responsibility. Like it's a must. They must. When they base their type from this type, what you are saying, you must provide implementation for this type. It's not an option. They have no choice. You force them to have an implementation of this type when they base their types from this type. So let's look at that. So now here is our student type, which we want it to be based from person. So once we do that, now we are forced to have an implementation of this type and all the other types that will be this member and all the members that will be defined within that abstract type. Cool. So we're going to have something like this within our student public. It should be override int get age. Now we need to provide an implementation. So then we're going to have our code there within that class. Now we have an implementation. Now you can create instances of students and then make use of the inherited members from the abstract person type. Are we together, people? So here's what you must note. Though you are not allowed to create an instance of an abstract type, you are allowed to do what? To take or to assign an instance of a type that inherit from an abstract type and assign it to a reference variable of type the abstract type. Jane. I say, though you are not allowed to create an instance of an abstract type person in this instance, you are allowed to create an instance of a type that inherits from an abstract type, students in this instance, because student inherit from person and person is an abstract type. So you are allowed to create an instance of student and assign the reference to that instance to a member variable of type the abstract class person in this instance. So you are allowed to do this. These cookie pen are very jealous. You are allowed to have person P1 is equals to new student. You are allowed to do this. This is fine because a student is a person. So that means we are allowed to take an instance of person, of student, and assign it to a reference variable of type person. But we are not allowed to create an instance of person. We are not allowed to create an instance of person, because person is an abstract class. So therefore, you cannot create an instance of an abstract class. Are we together, people? Sure. So now we're coming to the next thing.